So why we have to consider like material flow analysis for islands like Oahu? Actually, it's much easier to do for islands than a big country like the mainland, 48 states or 49 states contiguous. I mean, not contiguous with Canada in between, because there is a lot of traffic state to state which are not controlled. Here, at least we know what comes in, what goes out by ships, and we could be able to track them. So the advantage is the isolation is helping us, but we should take that in our favor to know what comes in, what goes out. We are completely import dependent, and the population density is very high. And also, in order to maintain a high standard of living, we need all the materials, plus tourists are here. And the storage space. So right now, the Waimanalo Gulch, here little gulch here, that is handling the waste for 1 million people. And it's supposed to be closed 2012, which I doubt it's going to happen because yeah, maybe I'll be held accountable for that. But the problem is that they have not thought through. Once you go through, you'll see there are some streams. There is no easy way to dispose of them unless there is a taker on the mainland, because the H power does not reduces all the wastes it produces. It takes 100 tons, and it can, if it takes 100 tons, it's going to produce 10 tons of ash. So right now the capacity is 3,000 tons per day burning, plus they are expanding another 900 tons, so 4,000 tons they will be burning by 2012. So that's going to produce 400 tons of ash. So that ash has to go somewhere. Right now it's going to a monofill at the Waimanalo Gulch. So then we have limited natural resources. Everything has to come from outside. And there are a number of executive orders coming up right now. The important of them is the President Obama's one, so which has certain goals that diversion to landfill, 50% diversion by 2020. So that's a significant goal. Even the military has come up with even more ambitious goals. By 2015, they want to achieve 50% diversion. So whether it's achievable or not, so that's where the material flow is going to play some role. Then sustainability, Hawaii 2050, that has also certain issues. There are energy independence and other diversion of the wastes and all that. Yeah.
Diversion, you mean?
Not going directly to the landfill. It's means the diversion word is very generic they use. So basically that what stream is going right now to landfills or even H power. So can that be diverted for some beneficial use or some other use, so that yeah, yes, yes. So in the same line, we have certain issues to deal with, that we have to have facilities to do this, and we have to meet the quality and quantity requirements. As I mentioned in the used oil case, we have to have quantity to refine this also. And the quality has to be somewhat meeting the standards, even if not civilian needs, at least the military or industrial needs it has to meet. And examples of like tires. On an average, I don't know, each household maybe 3 to 4 people, 2 cars. So how many tires you are producing every 4 years? Maybe 8 tires. So on an average, the islands, the state of Hawaii is producing about 750,000 tires per year. And then 100,000 of them are going to mainland for retreading. So the remaining are shredded and burned at the AES power plant. So that the power plant has certain amount of permit to burn alternative fuel, so it's doing okay in that sense. But there are some other issues, we'll be touching on those a little later. And then what about the glass? The High Five is producing so much glass. Right now the fuel price is about $75 to $78 a barrel. They're kind of breaking even, because every 6 cents you get back 1 cent, and that is 80% return. So basically the recycler is getting 2 cents for every bottle. So they are somehow managing right now, but if the fuel price is going to go up $100 or so, they cannot return it to the mainland. We don't have any processing or bottling facility. So what are some of the uses of this glass? Could we crush it or use it in some other manner so it can be beneficial? So one possibility that you cannot use glass in concrete, especially high strength concrete. There are some issues that glass is pure silica. So silica is going to react with a lime in the concrete, so it's going to form micro cracks. So there are applications for a low strength concrete sidewalks or some other things. But one could be golf courses, or could be some other use where it's aesthetics, landscaping. So I have already said that the price fluctuations are affecting the shipping and all that. There are other stocks also here, even cardboards. So, and we are also talking about off-island shipping, Oregon, Washington, shipment of solid waste. So the advantage is also to look into industrial symbiosis, that it's already happening a little bit in the Campbell Industrial Park, but as I said, the ash produced from edge power, right now 300 plus tons per day, that's being stored at Waimanalo Gulch landfill in the monofill. It doesn't go to the landfill, it's a separate storage area. But it's not being used for anything yet because it has some heavy metals, little dioxin, because they're burning the plastic along with the solid waste. So when you burn plastic, it forms dioxin at certain temperature. So they need to get a permit from the Department of Health so that they can use it for concrete. But there are some issues, so there is still potential. It's doable. And also during the combustion process here, although we don't need heat, but that heat can be used for certain processing or preparation, or maybe somebody looks into alternative energy issues. That's also possible. Then if we have to expand our recycling and reuse efforts, this flow of materials and stocks is going to be helpful. And then also we have to discover, it might help us to discover some new issues of concern. The one I said that the tire burning at the AES power plant, one sense, okay, we are getting rid of 600,000 tires or so. But each tire, I don't know if you know that these days the tires come with, it's a steel belted with a zinc in the steel. So 1% of the material of each tire is zinc. So if a tire is 10 pounds, that means 100 grams of that is going to be zinc. So strangely, I found it out little, we have a project with the Department of Transportation, monitoring, looking at the storm water injection into the ground so that we can prevent the coastal pollution. So on H3, directly under the H3, we are collecting the runoff and analyzing what comes outbound or inbound traffic. And then I found a lot of, especially the sediment coming out, we digested and looked at the content, a lot of zinc in the sediments. So where was it coming? Then finally did a little bit investigation looking at the sizes. They're about 10 to 20 micrometers. So they're tire shreds coming out of the concrete surface, washed off in the storm water. So then this, right now the tires being burned there, so they're producing some certain amount of zinc. Now the ash is going to PBT landfill, which is the construction and demolition landfill for a daily cover. So then we need to know what are the future impacts. Is it too much zinc? So those issues have to be looked into. So these are, you discover in a way that, okay, nobody looked into this holistic way of looking at what is happening inside the system. Then it can provide derive indicators of progress towards sustainability. Okay, what are the major goals? Are we achieving those or not? The executive orders or all these things coming up. Provide information on the eco-efficiency of economy and industry, in same way. And then again, finally, the supporting the policy debate that, okay, if they are going to close the landfill by 2012, so is it doable or not? So look at the sludge from the major treatment plants, Sand Island and Honolulu, or plus other plants. Do we have a facility to put them, or we have to ship it to the mainland? Who is going to take it?